what else can we do with these wonderful things called truth tables? Turns out, one very important thing you can do with truth tables is use them to test arguments for validity. This is perhaps the most fundamental thing that we're concerned with in this class. This class is logic. Logic is concerned with logical reasoning, with giving arguments, and the arguments that work deductively are called valid arguments. So if we can use truth tables to provide an infallible test of validity, that would be a very good thing. We've already seen other tests for validity. What specific test do you remember from the midterm? Venn diagrams, yes. Venn diagram was a test for validity, which was great as far as it went, but it had its limitations because it only works on a certain kind of argument. What kind of argument? A categorical syllogism. So it has to be A, categorical, and B, a syllogism, just two premises and a conclusion. It would be nice if we had a test for validity that worked on a wider range of arguments. And we do. It's the truth table test. Okay. So how does the truth table test work? Well, first of all, we need to remind ourselves, especially as many of you didn't do too well on this part of the test, on the definition of validity. Remember, validity is a feature of arguments. A valid argument is a logically good one, to put it vaguely. Why do people give arguments? People give arguments all the time. They give arguments to try and convince people of things. They try to convince people of their conclusions by showing that the conclusions, in some sense, follow from the premises. When this works, you have a valid argument. So what is an intuitive definition of validity?
When the premises guarantee the conclusion.
When the premises guarantee the conclusion. Now, what does it mean to say they guarantee it? Is it a law of physics or something? No. So what logicians decided is that you could characterize guaranteeing in terms of truth values. So the truth value based test for when an argument is valid is, and you might want to write this down, an argument is valid if the premises are true, the conclusion has to be true. In fact, an argument is valid if and only if the premises are true, the conclusion has to be true. So here we have a characterization of guaranteeing in terms of truth values. In other words, if the premises are true, the conclusion had to be true. And we saw why this was the case with Venn diagrams. Because we saw in Venn diagrams, the information in the conclusion of a valid argument was contained within the premises. So if the premises are true, in some sense the conclusion is automatically made true because the information is already there in the true premises. So making the premises true made the conclusion true already. Okay, so that's the truth value based test for validity. Now, that's the idea behind using a truth table to test for validity. So, let's consider two arguments. Here they are. What's this one called? Affirming the antecedent, also known as modus ponens. What's this one called? Affirming the consequent. One of them is valid, the other one is not. Which one is valid? The first one, affirming the antecedent. This one is not. Okay, now we've already talked about this, and I've used examples to try and illustrate this. Let's prove it now, that, that one is valid and the other one isn't. So, let's start with the invalid one. So we're going to prove that this is invalid using a truth table. What does the truth table look like? Well, guess how many rows it's going to need? 4 rows. Why? Because there's only 2 different letters involved. So, and also, we're going to need a column for each of those letters. P, Q. Remember what I called this part of the truth table? No, not sneeze. What's that?
Scaffolding.
Scaffolding, that's right. This is, I call this a scaffolding because basically it's something that enables you to construct your finished truth table, but isn't really part of the truth table. So, but you can set that up without even really thinking, although probably you should think when you're constructing actual scaffolding, otherwise there'll be workplace accidents. Alright, so it's going to look like this. And I'm going to draw a double line to separate it from the actual part of the truth table that we're going to care about at the end. Now what's that going to look like? Well, it's going to be 3 columns. One for each premise and one for the conclusion. So the first premise is if P then Q, draw a line. Second premise is Q. Then I'm going to draw another double line because there's an important distinction between the premise and the conclusion, as we'll see. Okay. Now, fill out that truth table. In other words, work out the truth values for each of these. Yes, you. I'm doing a poor job with it. Row. True, true, true. True premises and a true conclusion. Huh. Remember the definition of validity. The definition of validity was if the premises are true, the conclusion has to be true. Does this row prove that this argument is in fact valid? Spoiler alert. No, it doesn't. Because this is an invalid argument.
Must
So,
prove that it is not.
what's that?
If row 1 would prove that it is valid, then row 3 must prove that it is not.
Yes, in fact, row 3 is the important row. But let's go back to row 1 for a second. Here's the reason why that row does not prove that it's a valid argument. Because remember, the definition of validity is not the premises and the conclusion can be true together. It's the premises guarantee the conclusion. So why doesn't this show that the premises guarantee the conclusion? Well, think of this argument. Premise 1. Today is Wednesday. I'll use W for that. Premise 2. Whales are mammals. I'll use M for mammals. Conclusion. The Royals won last night. Is that a good argument? Is it a good argument? Why not? Because there's no way that those premises support that conclusion. Because to support a conclusion, you'd think they must at least be relevant, right? But there's no relevance. These are totally unconnected things. However, notice something about each of those. What is true about all 3 of these?
They are all in fact the case.
They are true. This is true, this is true, and this is true. Just like here. So, in other words, what I'm illustrating is it's possible for the premises and the conclusion to be true together without it proving that it's a valid argument, because this is clearly not a valid argument. How do we know it's not a valid argument? Answer, because it's possible for them all to be true together, but it's also possible for these to be true and this to be false. Next week it will be Wednesday. Next week whales will still be mammals, but the Royals will not have won the night before. So merely having a line like this does not prove the argument is valid. It just proves that it's possible for all the premises and the conclusion to be true at the same time. That's not enough. So what proves that it's invalid is, as Don has already said, row 3. Why does row 3 prove that it's invalid, not you?
Because both premises are true and the conclusion is false.
So what?
Well, in the top one, both of them are true and the conclusion's true, so you're getting conflicting.
No, actually, it doesn't even matter. Even if you didn't have that row there, this would still prove it. So it's not the conflict that's the problem.
Because if both of the premises are true, the conclusion has to be.
Yes, because if the premises guarantee the conclusion, then it should be impossible for this to happen. Clearly it's possible, because there it is. So if it's possible, what this shows is that it's possible for the premises to be true at the same time the conclusion is false. In a valid argument, that is not possible, because the premises guarantee the conclusion. So, in effect, the truth table method is a test for invalidity. Because what you're looking for is a line where all the, in this case, there are only 2 premises, but there can be 30 premises. I wouldn't do that to you, but it's possible. In that case, all of the premises have to be true at the same time, and the conclusion has to be false. If that is possible, and if it's possible, it'll be a line in your truth table, because remember, this truth table covers all possibilities, because it's only possible for P to be true or false, and there's only 4 possible combinations. So this covers all possibilities in the universe for this argument. If it's possible, it'll be one of these rows. And yes, it is. It is possible for the premises to be true and the conclusion to be false. That proves that this argument is invalid. Okay? All right, so the truth table test for validity is in fact a truth table test for invalidity. You're looking for a row where all the premises are true and the conclusion is false. And if you find it, it proves invalidity. Okay? Now, let's try it with modus ponens, which we know is valid. I'm going to be lazy. You should just redraw the entire table. But I'm going to take a shortcut. Okay, so we're going to pretend that wasn't a premise, and we're going to pretend that this is a premise and that this is the conclusion. So premise 1, premise 2, conclusion. Again, we're going to cover up the scaffolding now, because we don't need it. Now, this argument is valid. Is it valid because of this line? What's that? Is it valid because of this line? Yes or no? No. How do you know? Because we had exactly that line with an invalid argument. So if it's possible with an invalid argument, then that line cannot prove validity, right? Okay. So what about this table proves that the argument is valid?
It's not invalid.
Yes. It proves that it's valid because it's not invalid. In other words, to prove that an argument is valid, you've got to not find something. What have you got to not find? Where the premises are all true and the conclusion is false. So how many rows prove that an argument is invalid?
Just one.
Just one. So in other words, if you draw a table and you find on the first row true, true, false, you're done. The argument is invalid. You don't have to fill in any more unless I ask you to on your homework. Right? But in effect, you already know that it's invalid. However, if it's not true, true, false on the first line, or on the second, or on the third, you have to keep going until either you find the line or you finish the entire table. If you find the line, it's invalid. If you finish the entire table and you don't find the line anywhere, that's the only way to prove that it's valid. So you prove it's valid by proving that it's not invalid. In other words, by not finding the invalid line. So there's no line where it goes true, true, false. Every time the conclusion is false, one of the premises is false. Every time the premises are all true, the conclusion is also true. You never get true, true, false. Yes?
So the only time it's invalid is true, true, false.
Well, or, you know, depending on how many premises. If you have 30 premises, it will be true, 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 30 times false. Okay? Now, before we do some exercises, which we're going to do, I'm going to show you one little dirty secret about logic. One little oddity. Remember, we were working from a kind of intuitive concept of validity. An argument is valid if the premises guarantee the conclusion. And logicians come along and say, I can characterize guaranteeing in terms of this test, the truth table test. So, therefore, this is a test for validity. And in the vast majority of cases, it works. It matches up. We know that these premises guarantee this conclusion, and look, this proves it. The trouble is, there's a couple of cases where something weird happens, and this test says the argument is valid, when intuitively we would say that it isn't. Let me give you an example. Consider this argument. Here's the premise. It's Wednesday, and it's not Wednesday. Therefore, whales are mammals. Is that a valid argument? Do you think the premise guarantees the conclusion? No. Why not? Because the premise has nothing to do with the conclusion. How can it guarantee if it has nothing to do with it? Well, do the truth table test for that argument. All right, let's finish the table. And we'll keep going until you finish, till the rest of you finished it. And it should look like that. And once again, we can cover up the scaffolding because it's not relevant. What's weird about this? Yeah. What are we looking for? What's the test for validity? We look for something. What do we look for? True premise is a false conclusion. In this case, it's premise singular because it's a one-premise argument. You can have one-premise arguments. They're just not as common as syllogisms. Well, this one's one. So we're looking for a line where the premise is true and the conclusion is false. Do we find that line? No. So this argument is valid. Huh. That's a little weird. Why is it valid? Well, because it's not invalid. And why? But what's the kind of cheating reason why it's not invalid? Because, don't break your notes. Because this is what's called a logical contradiction. What does that mean? It's never true. It's not just false in one circumstance, it's false in every single circumstance. It's what's called necessarily false. There's no way that it could be true. So of course there's no case where the premises are true and the conclusion is false, because there's no place where the premise can be true. But that doesn't seem to mean that it's a valid argument, certainly not in our intuitive sense. Because it doesn't intuitively seem right to say that, it's Wednesday and it's not Wednesday, therefore whales are mammals. In fact, does it matter what the conclusion is? No, the conclusion could be anything you like and it would still be a valid argument. So in logic, we express this by saying you can derive anything from a contradiction. If your premise is a contradiction, then whatever your conclusion is, it's going to be a valid argument. Is it going to be a good argument? No. It's just a quirk of the truth test. There's one other kind of weird argument.
Sounds like garbage in, garbage out to me.
Yeah. There's another kind of weird argument that would do exactly the same thing. Only this time because of the conclusion. What would that be? Not when the conclusion is a contradiction.
Conclusion's always true.
When the conclusion is necessarily true. So in other words, an example of that would be P or not P. Why is that necessarily true?
It's always true.
Yes, why is it always true?
So if P is false, then not P is true. And
Yeah, because in a disjunction you only need one of them to be true, and that'll either happen because P is true, or if P is false, then not P will be true. So this is always going to be true in every possible circumstance. Why will anything that has that as the conclusion be a valid argument?
Because its conclusion is always true.
Yes, because you can never have
A false conclusion.
true premises and a false conclusion, because you can't have a false conclusion. So, you know, Elvis is alive, therefore today is Wednesday or it's not Wednesday. That's a valid argument. So that's a little weird. That's a case where the truth table test seems to veer a little bit away from what it's supposed to capture. But in all we allow logic that quirk because it's so useful and it works on every argument that intuitively is valid. And it also provides us some means for testing for validity very complicated arguments where we have no intuitions about whether it's valid or not. You know, suppose you had an argument with 20 premises. There's no way you could say, yeah, that's valid. You know, but you could test it using the truth table method. So it's useful. Turn to page 365, the number of days in a non-leap year. Nick, do you not have your book? You're just pondering deeply the nature of validity. Wrapped up in your thoughts. Okay, you don't have to do number 1 of practice quiz 13.1 because we've already done it. But you have to do all the others. So that includes over the page. And we can probably pause. No, I don't even need to know what this is. Yes, so now of course if I asked you in your homework to fill in every square, then you have to. But if I asked you work out whether or not this is valid, you would know by the time you reached here. Because provided you fill in all these, you know that once you've checked this one and this one, you know that there is no possibility of getting all true premises and a false conclusion. Okay. Number 6. Who have we reached? Jordan.
Valid?
You said what?
It was valid.
Valid. Okay. Who agrees? Yes, because where the conclusion is false, the premise is false. Where the premise is true, the conclusion is true. So there is no true-false combination. Are they logically equivalent? No. There's a difference here. So they're not logically equivalent. In fact, you could tell that that is a valid argument by De Morgan's law. We keep talking about De Morgan's law before we get to it. Eventually we'll get there. Pretty soon. Oh, that reminds me. I know that I've told my previous class, but I think I told them twice instead of telling them once and you once. I'm not going to be here next week. Did I tell you that? No. I know. I'll give you a moment to recover from your grief. But, however, maybe this will give you grief. We're not going to slow down. For a week, this is going to be an online class. Okay? So we're going to stick to the syllabus, except you don't have to show up here unless you want to see Eric. Are you going to show up? I mean, well, he won't bother showing up unless, you know, people email him, because I know you're free at this slot.
Yeah.
Yeah, you know, and he'll probably have his sessions the same as usual. But so there's going to be a homework, same as everything, and I am going to put little videos on the material, which let's see, yes, November 3 and November 5th. So I'm going to put little videos that cover this material on Blackboard. They're going to probably be fairly crappy quality because it'll be off my laptop from a cafe in Prague, so I'll be enjoying myself. Yeah, so we will cover this material despite me not being here. Just so you know. So if you show up bleary-eyed next Monday and the room is empty, now you know why. But yes, once again, there will be a homework, as usual. So it will be as if I'm here, only I won't be here. Good, now I've told you. All right. What about this one? Once again, it's an 8-liner. Boy, I'm running out. Samantha, where is this line? This row used to be packed. You've driven them all away. It's valid. Once again, I could be lazy and I could just do this one and notice that it's only false twice, and then I can check here, oh, one of the premises is false, oh, both the premises false. So we never get the true, true, false line. It's always one of the premises false or the conclusion is true.